Chapter 2.4 is quadratic equations. So far we've solved linear equations, which are degree 1 polynomials. Now we're going to be solving degree 2 polynomials, which we call quadratic equations. So a quadratic equation can be written in general form. It would be ax squared plus bx plus c equals 0. So everything's on one side, it's set equal to 0. A, b, and c here are real numbers. And the highest exponent, the largest exponent, is a2. So there's a couple different ways we're going to be solving quadratic equations. We're going to be solving them using factoring, using the square root property, by completing the square, and the quadratic formula. So starting with factoring, we're going to be using the same factoring techniques that we did previously, and then we're going to use what's called the zero product principle or the zero product property. The zero product principle says that if we're multiplying two or more things together, one of those things has to be 0. So that means if we have something like x times y equals 0, the only way to multiply to 0 is if either x is 0 or y is 0. So what we're going to do is we're going to factor it completely, and then we're going to set each factor equal to 0 and solve the remaining equations. So here are the steps for solving a quadratic equation by factoring. We're going to get everything on one side, so it's set equal to 0. We're going to factor it. So we're going to either factor it using greatest common factor or difference of squares, or factoring a degree 2 trinomial. And then we're going to apply this zero product property by setting each factor equal to 0. We're going to solve the resulting equations, and we can always check our answers in the original equation. So let's see this example right here. We have x squared minus 7x plus 10 equals 0. So it's already set equal to 0, so we can go ahead and factor this. So we're going to get x minus 5 times x minus 2, because we needed two numbers that multiply to 10 that added to negative 7. So this factors to x minus 5 times x minus 2 equals 0. And now that we have this completely factored, the only way to multiply these two things and get 0 is if one of them is 0. So what we can do is you can set it up like this if you want. That means either x minus 5 is 0 or x minus 2 is 0. And now we're going to solve these resulting linear equations. So on the left, we add 5 to both sides, we get x equals 5. On the right, we add 2 to both sides, we get x equals 2. And these are our answers. X equals 2 and x equals 5. I just wrote it as a solution set. And I'm not going to check every single one of these for time's sake, but let's check this first one. So checking for x equals 2, we go ahead and plug it in the original. That's 2 squared minus 7 times 2 plus 10. We want to see if that equals 0, so I'll put a question mark. And we get 4 minus 14, which is negative 10, plus 10 equals 0. And we get 0 equals 0, so this one works out. And we would also check for x equals 5. So for x equals 5, we would get 5 squared, plugging it in the original, minus 7 times 5 plus 10 equals 0 with a question mark. That's 25 minus 35, so negative 10, plus 10 equals 0. And this one also gives us 0 equals 0, so we know that we did it correctly. Okay, now for the next one here, let me just move this other stuff up a little bit. Okay, so we have x squared plus 15x equals negative 54. So first we have to get everything on the same side, so it's equal to 0. So we have to add 54 to both sides. So we get x squared plus 15x plus 54 equals 0. And now we can try to factor it. So once again, we need two numbers that multiply to 54, that add to 15. So that's going to be 9 and 6. So this is going to be x plus 9 times x plus 6. Once we have it completely factored, we're going to split it off and set each factor equal to 0. x plus 9 equals 0, and x plus 6 equals 0. And solve these separately, so subtract 9 on the left, we get x equals negative 9. Subtract 6 on the right, we get x equals negative 6. Okay, and then I wrote the two solutions as a solution set. So you probably recognize here that we got two solutions for both of the first two. When we were solving linear equations, we typically got one answer, or we got none, or we got an infinite amount. Now when we're doing quadratic equations, we can either get 0 solutions, 1 solution, 2 solutions, or infinitely many solutions. So we'll see that most of the time here we're getting 2 solutions. So let's do another one. So we have 4x squared minus 2x equals 0. So this one isn't the same as the previous two. This one's going to be GCF factoring. So we can factor out a 2x. If we factor out a 2x, we're going to be left with 2x minus 1 equals 0. And this is completely factored. We're going to set each of these equal to 0. So we have 2x equals 0 and 2x minus 1 equals 0. On the left, we divide both sides by 2, and we get 0 over 2, which is 0. On the right, we're going to add 1 first, then get 2x equals 1, and then divide by 2. So we get x equals 1/2. So we get two answers once again. We get x equals 0 and x equals 1/2. For this next one, we have negative 2x squared minus 7x equals negative 4. So for this one, a nice little trick to keep in mind is it tends to be a little bit easier if this x squared term is positive. So to make that positive, let's get these two terms over on the right. So to do that, we're going to have to add 2x squared to both sides, and we have to add 7x to both sides. So that's going to give us a 0 on the left-hand side. So it's 0 equals 2x squared plus 7x minus 4. This time there's no GCF here, and it's going to be a little bit more difficult because we have this coefficient of 2. So to factor this one, we have to think back to how we did it during the factoring section. This is going to factor to 2x minus 1 times x plus 4. And the way that I did these ones when I went over it in the notes is I would do it essentially by grouping. I would rewrite that middle term and do it by grouping. So if you need a refresher, go back and look at that section. So once we have this factored, we're going to set each one of those factors equal to 0. And it doesn't matter that 0 is here on the left. We could have rewritten it and made it on the right-hand side. It doesn't matter. So this is going to be each factor equal to 0. And on the left-hand side, we're going to add 1 and get 2x equals 1. Divide by 2 gives us x equals 1/2. And on the right, we're going to subtract 4 and get x equals negative 4. Okay, so we get our answers x equals 4 and x equals 1/2. Let's do a couple more here. So we have x times x minus 1 equals 2. So a common mistake for this one is seeing that it's factored over here and then setting each one of those factors equal to this 2. But you cannot do that. You can only do that with the 0 product property, meaning that number on the right has to be 0 to do that. So you can't do that here. So what we have to do is distribute the x. And we get x squared minus x equals 2. Now let's get the 2 over on the left-hand side. We have to do that by subtracting it. So x squared minus x minus 2 equals 0. And factoring this one, two numbers that multiply to negative 2 that add to negative 1. It's going to be x minus 2 times x plus 1. So that one factored nicely. We set each one of these equal to 0. X minus 2 equals 0. X plus 1 equals 0. And on the left, we add 2. We get x equals 2. On the right, we subtract 1. And we get x equals negative 1. Okay, and then for this one right here for this last one. Definitely the messiest one that we've done. We have x plus 3 squared equals 2 times 9x minus 5 minus 1. So what we're going to have to do here is expand everything out, which is just going to be distributing, combining like terms, and then get everything on the same side, so it's set equal to 0. So on the left-hand side, x plus 3 squared, if we FOILed that out, or hopefully we know the shortcut, we get x squared plus 6x plus 9 on the left-hand side of the equation. On the right-hand side, let's distribute the 2. So we get 18x minus 10 minus 1. And on the right-hand side here, let's just rewrite the left-hand side. On the right side, let's combine like terms. We get negative 10 minus 1, so negative 11. And now let's get everything on the left-hand side. So let's subtract 18x and add 11 to both sides. So subtracting 18x is going to be 6x minus 18x, so negative 12x. 9 plus 11 is going to give us 20. So we get x squared minus 12x plus 20 equals 0. And this one is going to be a lot easier to work with now. Two numbers that multiply to 20 that add to negative 12. It factors to x minus 10 times x minus 2. And now we're just going to set both of these equal to 0. And I'm guessing we can probably do these in our head by now. But we get x minus 10 equals 0, x minus 2 equals 0. So on the left-hand side, we get x equals 10. On the right-hand side, we get x equals 2. So we get our two answers, 2 and 10. So the next method we're going to be using is solving quadratics using the square root property. And this is going to come in handy when we have quadratics that are missing the x term. So something like ax squared plus c equals 0. So you can see there's no x term here. And we'll see this can look a little bit differently for the last couple examples. So what we're going to do is we're going to isolate the x squared term, meaning we're going to solve for the x squared term, get it on one side of the equation by itself, and then we're going to take the square root of both sides, and then we're going to solve it for x. So when we take the square root of both sides in an equation, it's going to always result in a positive and a negative answer. So that means if we have something like x squared equals a number, k, then that's going to give us x equals the square root of k and x equals negative square root of k. And the way that we can write this is plus or minus, so x equals plus or minus the square root of k. Okay, so real quick for the reason why we get two answers. Let's say we had x squared equals 4. If we wanted to solve this, we would take the square root of both sides. The reason why we do this is because square root will cancel the squared. But on the right-hand side, what we get is plus or minus the square root of 4. So the square root and the square cancel, and we're just left with x, which is what we wanted. We get plus or minus the square root of 4, so we get negative 2 and positive 2. So the original question was x squared equals 4. So if we plug in negative 2 into our original, we would get negative 2 squared equals 4, which is true because negative 2 squared is positive 4. And positive 2 squared would also work. 2 squared is 4, so we get 4 equals 4. So that's why we get a positive and a negative answer, because when we go back and check it, and we plug in a negative and we square it, it's always going to end up being positive and give us the desired result. Okay, and then one more other concept here. If we have x squared equals 4 again, and we said that our answer was plus or minus 2, so negative 2 and positive 2, there is a difference between just evaluating the square root of 4. The square root of 4 only equals positive 2. So if we have x squared equals 4, that gives us positive and negative 2 as our solution. If we just have the square root of 4, that simplifies to just positive 2. So they're a little bit different even though they look kind of similar. Okay, so let's go on to these examples here. So this first one we have 2x squared minus 8 equals 0. So hopefully we can see the difference between this one and the last one that we did. Technically we can factor this, but it's kind of unnecessary. So let's go ahead and let's go ahead and solve for x squared. We have to isolate the x squared here. So we have to do that by first adding 8 to both sides. So we get 2x squared equals 8. Now let's divide both sides by 2 to get rid of that 2. So we get x squared equals 8 divided by 2, which is 4. And once we get this, now we take the square root of both sides. Remember, when we square root x squared, it cancels it. So it's just x on the left. And then we always get plus or minus, so plus or minus the square root of 4. So we end up getting x equals plus or minus 2. And as a solution set, we have negative 2 and positive 2. Just so we know that technically those are two different answers there. Okay, so doing the next one here, we have 3x squared minus 15 equals 0. So once again, recognize we don't have an x term, so we can isolate the x squared term and take the square root. So let's add 15 to both sides. So we get 3x squared equals positive 15. Divide both sides by 3 to isolate the x squared. 15 divided by 3 is 5. And now we're going to take the square root of both sides, cancels the squared. We get plus or minus the square root of 5. So this doesn't simplify, right? This is not a perfect square, and it also just can't be simplified any further. So we're going to leave it just like that. So our solution is negative square root of 5 and positive square root of 5. Let's do two more here. We have 9x squared plus 25 equals 0. So we have just an x squared here. So once again, what we can do is we can isolate it. So subtract 25 on both sides. We get 9x squared equals negative 25. Divide both sides by 9. We get x squared equals negative 25 over 9, which doesn't look like this simplifies at all, so it's kind of messy. And then we're going to take the square root of both sides. So we get the x by itself now, and we get plus or minus the square root of negative 25 over 9. So what we should recognize here is we have a negative under the square root, so we're going to get an imaginary answer. So it's going to be plus or minus, I'm going to rewrite this as plus or minus I times the square root of 25 over 9. So essentially I split it up and took out the square root of negative 1 and just rewrote that as I. And now we can take the square root in the numerator and denominator separately. The square root of 25 is 5 and the square root of 9 is 3. So this is going to be plus or minus 5/3 I. So definitely a little bit messy for this one. We get those two answers, negative 5/3 I and 5/3 I. So for this one, there were no real number solutions. So we say no real solutions. Our answers were imaginary solutions. Okay, so one more for this part. We have x minus 2 squared equals 6. So this one looks a little bit different, right? We have kind of two options here. The first option being we could FOIL out this x minus 2 squared and rewrite it as x minus 2 times x minus 2, expand it, get everything on one side, set equal to 0, see if we can maybe factor it. This one actually would not factor. So the easier way to do this one is recognize that this whole entire left-hand side is raised up to the second power. It's already squared. So what we can do is apply the square root property right now. We don't only need the x squared to do this, but we can recognize that we can apply it right away. So if we take the square root of both sides, it cancels the square root on the left, and then we get plus or minus the square root of the other side, so plus or minus the square root of 6. And then all we have to do here is get this 2 over on this side to solve for x. So we have to add it to both sides, and I'm going to write it first. It's usually good practice to write the square root last. So instead of plus or minus square root of 6 plus 2, I'm going to write 2 plus or minus the square root of 6. Okay, so this is obviously going to be a decimal here because of the square root of 6. So we end up getting 2 minus square root of 6 and 2 plus square root of 6. We can leave it just like that. It doesn't simplify. So those are our two answers for this one. So the next way we're going to be solving quadratic equations is going to be completing the square. So if we have a trinomial ax squared plus bx plus c equals 0, and it cannot be factored, another way to do this is going to be, like I just said, completing the square. So what this means is we're going to be rewriting a trinomial as a binomial squared, and this is going to help us because then once we have a binomial squared, we can take the square root of both sides and solve it for x. Okay, so let's say we have some expression x squared plus bx, and we want to write this as a binomial squared. If we add b over 2 squared, this will result in a perfect square trinomial. So what that means is that if we have x squared plus bx plus that b over 2 squared, we can actually rewrite it as x plus b over 2 all squared. So it factors to x plus b over 2 times x plus b over 2. Okay, and once again, this comes in handy because then we can just take the square root of both sides of the equation and solve it for x. And notice that the a value, the x squared coefficient, is a 1 in this previous example I just said. That's essentially for simplicity. If it's not equal to 1, if we have a coefficient on the x squared that's not 1, we have to divide everything by a, so we do get a 1 as the coefficient. Okay, so let's go over these steps for completing the square. So if we have x squared plus bx plus c equals 0, so once again we have an a coefficient on the x squared term, what we're going to do first is we're going to add or subtract the constant term, the c value, to the right side of the equation. And then the next step that we have to know to do is add b over 2 squared to both sides of the equation. What we're going to get on the left is a perfect squared trinomial, and then we can factor it. So what we're going to get on the from x squared plus bx plus c equals 0, it's then going to become x plus b over 2 squared equals negative c plus b over 2 all squared. And then we're going to use the square root property, square root both sides, and solve it for x. So it seems really confusing. We'll do an example in 1 second, but for just a quick example here, let's say we had x squared plus 6x plus 9, and we wanted to factor this. We know this factors to x plus 3 times x plus 3, and we can write that as x plus 3 squared. So since we were able to write this trinomial as a binomial squared, that means this original trinomial is a perfect square trinomial. Okay, so let's do a couple examples here. So the first one, we have x squared minus 6x plus 4 equals 0. So solving this by completing the square, so what we have to do is first subtract 4 on both sides to get the constant on the right hand side. So it's going to be x squared minus 6x equals negative 4, subtracting 4 on both sides. And the next step is to look at this x coefficient, that's our b value. That's going to be b over 2 squared that we're going to be adding to both sides. So negative 6 over 2 squared, which is negative 3 squared, which is 9. So we're going to be adding 9 to both sides of this equation. What we get on the left is x squared minus 6x plus 9. On the right, we get negative 4 plus 9, we get 5. Okay, so what we just created on the left-hand side of this equation now is a perfect square trinomial. We can factor this to x minus 3 times x minus 3, but you can just skip right to rewriting it as x minus 3 squared. And now all we have to do is take the square root of both sides. So taking the square root on the left cancels the squared. On the right we get plus or minus the square root of 5. And now we just have to add 3 to both sides. Okay, so adding 3 we get x equals 3 plus or minus radical 5. And let's just write that as a solution set. We get 3 minus radical 5 and 3 plus radical 5. Okay, so and a shortcut for this too is recognizing this value right here that's going to go in your binomial squared is going to be your b over 2 value before you square it. It's that negative 3 in this case. Okay, so let's do another one. We have x squared plus 4x minus 1 equals 0. So first step, we need to add 1 to both sides. So we get x squared plus 4x equals positive 1. And now we have to complete the square. So we'll look at the x coefficient. That's going to be our b value. So we do b over 2 squared. That's 4 over 2 squared, which is 2 squared, which is 4. So we're going to add 4 to both sides. So on the left-hand side, we get x squared plus 4x plus 4. On the right-hand side, we get 4 plus 1, so we get 5. And now we just created a perfect square trinomial on the left. We can factor it as x plus 2 times x plus 2, which would be x plus 2 squared equals 5. Now we can go ahead and take the square root of both sides, so we get x plus 2 equals plus or minus the square root of 5. And subtract 2 on both sides, we get negative 2 plus or minus radical 5. And let's write this as a solution set. We get negative 2 minus radical 5 and negative 2 plus radical 5. And once again, recognize that the value that goes in these parentheses is the b over 2 value before we squared it. Okay, let's do one more of these. We have 2x squared equals negative 3x plus 4. So let's get the negative 3x on the left-hand side by adding it to both sides. So we get 2x squared plus 3x equals 4. And also recognize here that we actually have to divide everything by 2 because there's a coefficient other than 1 on the x squared term. So divide everything by 2, which just means we're dividing every term by 2. So that's going to be 1x squared plus 3 halves x equals 4 over 2 is 2. And now we can go ahead and complete the square. So we take a look at this coefficient on the x term right here, and that's going to be our b. So we get 3 halves over 2 squared, which is 3 over 4 squared, which is 9 over 16. Okay, so we're going to add 9 over 16 to both sides, so it's a little bit messier because we're dealing with fractions, but it's the same exact concept. So on the left-hand side, now we have x squared plus 3 halves x plus 9 over 16 equals, on the right-hand side, 2 plus 9 over 16. Getting common denominators, that would be the same as 32 over 16 plus 9 over 16, which would be 41 over 16. So that's going to be on the right-hand side. And now we can go ahead and factor it on the left. So x, the number that we're using here, it's obviously harder to factor it when we have fractions. This is when that shortcut's going to come in handy, and we know that this number is going to be plus 3 over 4 because that was our b over 2 value. So it's x plus 3/4 squared equals 41 over 16. And now we can go ahead and square root both sides. We get x plus 3/4 equals plus or minus the square root of 41 over 16. And we have to subtract 3/4 on both sides, so negative 3/4 plus or minus radical 41 over 16. So what I'm going to do is I'm going to square root the numerator and denominator separately. The square root of 41, you can just leave it just like that. The square root of 16 is 4. So there we go, we have our answers. Negative 3/4 minus radical 41 over 4 and negative 3/4 plus radical 41 over 4. Definitely a little bit messier, but same concept. Okay, so this brings us to the last way that we're going to be solving quadratic equations, and this is going to be the quadratic formula. So make sure you have this formula memorized going forward. So if we have a quadratic, ax squared plus bx plus c equals 0, and we want the solutions to them, we can actually plug in our a, b, and c numerical values into this formula. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So this will either give us 0 real solutions, 1 real solution, or 2 real solutions. So this will always work for any quadratic as long as you have it set equal to 0 first. Okay, so let's derive this formula so we can see where this comes from. So let's say we have this original, or this generic ax squared plus bx plus c equals 0 equation. What we have to actually do to get this formula, to create this formula, is to complete the square on it. So if we're completing the square on this, what we have to do is first we're going to subtract the constant on both sides. So it's going to be ax squared plus bx, subtract c on both sides, so equals negative c. And now what we have to do is we need this coefficient to be a 1, so we have to divide everything by a. So we're going to divide everything by a here, and what we're going to get is a divided by a is 1, so x squared plus b over a, x equals negative c over a. Okay, so it looks pretty confusing, but always just keep in mind that all we're trying to do here is solve for x. So now for completing the square, we have to go to this value on the x coefficient, just like we've been doing, and we're going to take that and divide it by 2, and we're going to square it. So b over a divided by 2 simplifies to b over 2a squared. And while we're here, let's just square the numerator, which is b squared. Let's square the denominator, which is 4a squared. So we're taking this and we are adding that to both sides of the equation. And when we do that, on the left-hand side, we're going to get x squared plus b over ax plus b squared over 4a squared. On the right-hand side, we're going to get b squared over 4a squared minus c over a. Okay, so it looks pretty complicated still, but what we just did, we just completed the square on the left-hand side, and we can rewrite this as x plus or minus something squared. And to figure out what goes in with this binomial, this is where we have to remember the shortcut. It's going to be this value right here before we squared it. So this is going to be plus b over 2a squared, and that's going to equal that right-hand side, b squared over 4a squared minus c over a. Okay, so once we have this, we're getting close to being done here. We just have to solve it for x. When we solve it for x, that will result in the quadratic formula. So we have to square root both sides. So we're going to get x plus b over 2a on the left, cancels with the squared. On the right, we get plus or minus the square root of b squared over 4a squared minus c over a. So on this right-hand side here, what we can do is we can get common denominators for those two terms under the square root. So a common denominator here would be 4a squared. So in order to get the second fraction to be 4a squared, we have to multiply by 4a over 4a. So what we're going to end up getting is x plus b over 2a equals plus or minus b squared over 4a squared minus 4 times a times c all over 4a squared. And now what we can do is we can combine those terms under the radical into one fraction. So it's going to be plus or minus. They have common denominators, so all we have to do is subtract the numerators and put them over that common denominator. And now let me just move everything up on this page. Okay, on the right hand side of the equation now, we can square root the numerator and denominator separately. So if we square root the numerator, that would be b squared minus 4ac. If we square root the denominator, the square root of 4a squared is 2a. Okay, so all we have to do now to solve for x, remember, keep in mind we're always trying to solve for x, is we have to subtract b over 2a on both sides. So when we do that, we're going to subtract b over 2a. We're going to get negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. And if we combine these into one big fraction because they already have common denominators, what we're going to get is negative b plus or minus the square root of b squared minus 4ac all divided by 2a, which is the quadratic formula. Okay, so this is where the quadratic formula comes from. It's the derivation of it by completing the square on ax squared plus bx plus c. Okay, so let's do a couple examples using this formula. So let's solve x squared plus 5x plus 6 equals 0. Okay, so let's write down the quadratic formula here. So we have the quadratic formula, and we recognize that this is already in the form ax squared plus bx plus c equals 0. So we can go ahead and read off our a value, which is 1, our b value is 5, and our c value is 6. And we can go ahead and plug these in and simplify. So it's going to be negative 5 plus or minus 5 squared minus 4 times 1 times 6. So recognize here that for the b squared value for 5 squared, I didn't put 5 in parentheses. The only reason I didn't do that is because it was positive. If it's negative, you need it in parentheses. So this is going to be all divided by 2 times a, which is 2 times 1. And all we have to do is simplify this to get our answers. It's negative 5 plus or minus square root of 25 minus 24, all divided by 2. And we're going to get a 1 as the radicand. So it's x equals negative 5 plus or minus the square root of 1 over 2. The square root of 1 is obviously equal to 1. So it's negative 5 plus or minus 1 over 2. So anytime you take the square root and it's a perfect square and the square root ends up being gone, you're going to want to simplify this further. You're going to want to split this up and say that means x is negative 5 minus 1 over 2, or x equals negative 5 plus 1 over 2. So simplifying both of these separately now, we get x equals negative 6 over 2, which is negative 3, or we get x equals negative 4 over 2, which is negative 2. So these are our two solutions here. As a solution set, we get -3 and -2. Okay, so if you go back and look at the original question here, you recognize that you could actually factor this one, and you'd have gotten the same answer. So a couple more. We have 2x times 4x plus 1 equals 1. So first we have to get this into ax squared plus bx plus c equals 0 form. So first we have to distribute the 2x. So we get 8x squared plus 2x equals 1. And then we have to subtract 1 on both sides to get it on the left. So ax squared plus 2x minus 1 equals 0. Okay, so now we have it in the correct form, so we can go ahead and use the quadratic formula. So we have our quadratic formula, and we have our, based on this equation right here, our a value is 8, our b value is 2, and our c value is -1. So you have to be a little bit careful with the positives and negatives. And plugging all of this in, we're going to get x equals -2 plus or minus the square root of 2 squared minus 4 times 8 times -1, all over 2 times 8. And now you can simplify. So underneath that square root, we get 4 plus, so we have minus a negative, so it ends up being plus 4 plus 32 over 16. And 4 plus 32 gives us 36, so it's -2 plus or minus the square root of 36 over 16. So once again, 36 is a perfect square here, so we can go ahead and simplify this. It's -2 plus or minus 6 over 16. And we can split these up into our two separate solutions. That's -2 minus 6 over 16, or x equals -2 plus 6 over 16. So -2 minus 6 gives us -8 over 16, which is -1/2. And then on the right-hand side, we have -2 plus 6 gives us 4 over 16, which is 1/4. So these are our two solutions. We have our solution set, -1/2 and 1/4. And keep in mind, you can always go back and plug these in the original, make sure that it gives you a true statement. Okay, next one we have -6x plus 1 equals -2x squared. So first we have to get everything on the same side. So let's move this term over here to the left. So we have to add 2x squared to both sides. That gives us 2x squared minus 6x plus 1 equals 0. And now we can go ahead and use the quadratic formula. We have an a value of 2, a b value of -6, and a c value of 1. Okay, so let's go ahead and plug all of these in. So we get x equals, so it's -b, so it's -6. I'm just going to write +6, plus or minus the square root of -6 squared. So notice I put parentheses around the -6 this time, minus 4 times 2 times 1. And that's going to be all divided by 2 times 2. And simplifying this a little bit, we get 6 plus or minus the square root of 36 minus 8 over 4. Okay, so always keep in mind that the b squared term is going to be positive. And now we can simplify underneath that square root a little bit more. So we get 6 plus or minus 36 minus 8, we get 28 divided by 4. So the square root of 28, that does not give us 28 is not a perfect square, but we can simplify it. The square root of 28 we can rewrite as the square root of 4 times 7, which is the square root of 4, which is 2, times the square root of 7. So we can rewrite it like that. So it's x equals 6 plus or minus 2 radical 7 over 4. So when you're simplifying this, we have two terms in the numerator, so you would have to simplify both of those at the same time with the denominator. An easy way to kind of recognize how to do this would be to split up the fraction and write it as 6 over 4 plus or minus 2 radical 7 over 4. And now simplify those separately, and you would get 3 over 2 plus or minus 1 radical 7 over 2, so just radical 7 over 2. And you can leave it like that if you want, or you can put it back together for your solution set. Either way, that's as far as you can go. So for the solution set, I will just put them back together as one fraction and write it as 3 minus radical 7 over 2 and 3 plus radical 7 over 2. Okay, so those are our two answers here. A little bit messy with the square root, but that is okay. Okay, so we'll do two more of these ones. So we have 3x squared equals 2x minus 4. So let's get everything on the same side. So let's subtract 2x and add 4. And that's going to give us 3x squared minus 2x plus 4 equals 0. And that gives us our a value is 3, our b value is negative 2, and our c value is 4. So using the quadratic formula here, going to plug in our a, b, and c. We have x equals negative negative 2, so positive 2 plus or minus the square root of negative 2 squared minus 4 times 3 times 4. And that's all under the square root, all divided by 2 times 3. Okay, so let's simplify. So it's x equals 2 plus or minus the square root of 4 minus 4 times 3 times 4 is going to give us 48 divided by 6. So simplifying under that square root, we get 2 plus or minus the square root of negative 44. So as soon as we see that negative under the square root, we should be thinking imaginary numbers. So let's go ahead and do that. So the square root of negative 44, I'm going to do that on the side just to save some room. That's going to be the same thing as I times the square root of 44, essentially factoring out that square root of negative 1 and rewriting it as an I. The square root of 44 can be rewritten as the square root of 4 times 11. The square root of 4 is 2, so that's 2i radical 11. Okay, so let's replace that into this formula here. So it's 2 plus or minus 2i radical 11 over 6. So what we could do here is we could split up the fraction like I did in the previous one, and so we can simplify each of the terms separately in the numerator. What I'm going to do though is recognize that we can cancel off a factor of 2 with all three of these terms, and if we cancel off a factor of 2, we're going to have x equals 1 plus or minus 1i radical 11 over 3. Okay, so that was from a factor of 2 being canceled off. I just kind of did it in my head without splitting up the fraction. And those are our two answers. We can't simplify this any further. So it's going to be our solution set is 1 minus I radical 11 over 3 and 1 plus I radical 11 over 3. Okay, so there are no real solutions to this one. It was only imaginary solutions. Okay, and then for this last one here, we have 2x squared equals 8x. So first, let's get everything on the same side set equal to 0. So we're going to subtract 8x to the left-hand side. And we get 2x squared minus 8x equals 0. And now we have the quadratic formula. And our a value is going to be 2 our b value is negative 8, and our c value, we do not have a constant term, so our c value is 0 here. Okay, so let's plug all of these in. We get x equals negative 8, so that's just positive 8, plus or minus the square root of negative 8 squared minus 4 times a times c all over 2 times 2. And simplifying under the radical, we have 8 plus or minus the square root of, it's going to be 64 minus 0, so it's just the square root of 64 all over 4. And that's going to give us 8 plus or minus 8 all over 4. Square root of 64 is 8. So now we can split this up into our two separate cases. We have x equals 8 minus 8 over 4, or x equals 8 plus 8 over 4. And for the one on the left here, we get x equals 0 over 4, which is obviously 0. And the one on the right, we get 16 over 4, which simplifies to just 4. Okay, so that is our solution set. We have 0 and 4. So hopefully you realize when we originally got everything on the same side set equal to 0, this would have been one of the examples that could have actually factored for us. Okay, so for the last thing for this section is the discriminant. So the discriminant is part of the quadratic formula. It's the part that's under the radical or the radicand. So the discriminant is b squared minus 4ac, and this is important because this actually determines the number and type of solutions for the quadratic equation. So we only have 3 different conditions, which are all right here. Either the discriminant is positive, 0, or negative. If the discriminant is positive, that's going to mean that we're going to have 2 real solutions. Graphically speaking, this would be the parabola intersecting the x-axis twice. If the discriminant equals 0, that means we're going to have 1 solution, which means the vertex of the parabola would be touching the x-axis. And lastly, if the discriminant is negative, that means there's no real solutions. There would be imaginary solutions, which means there's no x-intercepts. So if it's negative, it would be the square root of a negative number, giving us imaginary answers. Okay, so for example, for each one of these, let's compute the discriminant and determine the number and type of solutions. So we have 3x squared plus 4x minus 5 equals 0. So our a value is 3, our b value is 4, and our c value is negative 5. And we have our discriminant is b squared minus 4ac. So we plug everything in, we get 4 squared minus 4 times 3 times negative 5. And this is going to equal 76. So this is obviously positive. And since it's positive, this means we would get, if we went and solved this using the quadratic formula, we would get 2 real solutions. Okay, so we're not going to go through and do it, but if you did it, you'd get 2 real solutions. For the next one, we have 9x squared minus 6x plus 1 equals 0. We have an a value of 9, b value of negative 6, c value of 1. We calculate the discriminant, b squared minus 4ac. We plug in our values. We get negative 6 squared minus 4 times 9 times 1. That gives us 36 minus 36, which gives us 0. And since the discriminant equals 0, that means we would get 1 real solution if we solve this one. So the reason we would get 1 real solution, so if we went to, I won't do the whole thing here, but if we went to solve this equation using the quadratic formula, we would get x equals 6 plus or minus the square root of 0 over 18. Since this discriminant is 0, it's going to be x equals 6 over 18, which is 1/3. So we only get one answer here. That plus or minus kind of doesn't matter at all because it was just plus or minus 0. Okay, and now for this last one here at the bottom, 3x squared minus 8x equals -7. So first we have to get this in the proper form. So we have to add 7 to the left-hand side. And we get this. And now we can read off our a value is 3, our b value is -8, and our c value is 7. And calculating the discriminant, b squared minus 4ac is going to be -8 squared minus 4 times 3 times 7, which would give us -20, which is obviously negative. So when we get a negative discriminant, this would give us square root of a negative number, which means we would get 2 imaginary solutions. So this would be no real solutions. Okay, so we would have an I in our answer for that last one. Okay, so for the last page here, kind of like a summary for this section for how to determine which technique to use, either factoring, square root property, completing the square, or quadratic formula. For the first thing here, if the quadratic has all of the terms in it, ax squared plus bx plus c equals 0, and it can be factored easily, then factor it and use the zero product principle. So for example, something like x squared plus 5x plus 6 equals 0. We know it factors to x plus 2 times x plus 3 equals 0, and we would solve this and get x equals 2, -2, and x equals -3. And for the second method here, the second option, if we have a quadratic with no constant term, meaning it's in the form ax squared plus bx equals 0, what we can try to do is factor out the GCF and use the zero product principle. So for example, 3x squared minus 6x equals 0. There's no constant term here. So there's a GCF of 3x that we can factor out. We'd be left with x minus 2. Zero product principle, set them both equal to 0 and solve. And we would get x equals 0 and x equals 2. And for the next one, if the quadratic has no x term, so if we have something like ax squared plus c equals 0, we can solve for the x squared and apply the square root property. So for example, if we have 2x squared minus 32 equals 0, there's no x term here, so we can add 32 to both sides and get 2x squared equals 32. Divide both sides by 2 and get x squared equals 16. And when we take the square root of both sides here, we're going to get x equals plus or minus the square root of 16, which gives us plus or minus 4. So -4 and +4 for that one. And for the next one, if the quadratic is in the form x plus c squared equals d, we can apply the square root property and solve for x. So, for example, for this one, if we had x minus 4 squared equals 5, since one side is completely being squared, we can square root both sides right away. And it cancels the squared on the left. And on the right, we get plus or minus the square root of 5. All we have to do is add 4 to both sides, 4 plus or minus the square root of 5, and writing that as a solution set. That would give us 4 minus radical 5 and 4 plus radical 5. And for the last one, if we have a quadratic, ax squared plus bx plus c, and it cannot be factored easily, we can use the quadratic formula. So keep in mind that this one will always work. So make sure we have this quadratic formula memorized. So for example, we have 2x squared minus 6x plus 1 equals 0, and we recognize that cannot be factored easily. So we can go ahead and run this through and plug it in the quadratic formula like we've been doing. And we would get x equals 3 plus or minus radical 7 over 2. Okay, so notice I didn't put completing the square on here for these methods. Definitely no completing the square also. The only time you have to do it though is if the question says to do it. If it doesn't say to do it, the quadratic formula will always work. Okay, so that is it for this section.